everybody, to this wonderful show. My task today is to introduce you the European Composite Association and to highlight some of the recent initiatives that we have been running in the last few years. The EUCIA association is a so-called second-level association, so we don't have companies as members of the association, but the main members are the country representatives. You see that most of the Central and Northern Europe is represented, is the green areas in the map on the right, as well as Turkey. So we work together to make sure that the composite materials are known, so people know what composite materials are. They know also what are the advantages of using composites instead of other materials in many structural and non-structural applications. And we make sure that the composite European market may grow by lobbying at the European Commission in order to monitor all the political and economical processes which are running over there. We represent roughly 10,000 European companies and which have roughly 150,000 employees. So it's not a very big market, but it's still significant. The association is also in the association, some sector groups are also represented. So these are associations that are representing specific technologies, like the EPTA Association, which is the European Pultrusion Technology Association, or they are representing raw materials, like Glass Fiber Europe, CEFIC, which is the European Association for Chemistry, Chemical Products, and the SMC-BMC Alliance are also part of EUCIA. So, generally speaking, EUCIA is an umbrella organization which groups together all the associations which have an interest in composite materials today. The size of the European market, these are data of the last year, is about 2.3 million tons per year, which are roughly half short fibers and half long fibers. Usually short fibers are injection molded thermoplastics, and long fibers are mainly thermosetting resins, but this is also changing a little bit in the recent years, and more you see long fiber thermoplastics as well. Of course, the structure and composition of materials is a little bit more complicated than with other more conventional materials, so you always have to explain to people, not to you, because if you are here, you probably know more than what is in this slide, but you have to explain to people that this complex structure is a benefit, is not a drawback for the material, because you can tailor your material. You have so many variables that you can adapt your material to virtually any specific application. One of the major challenges today is, of course, the environmental impact of the production of materials, not only their disposal, which is a major issue for plastics, for example, today worldwide, but also for the production. This process, which monitors the environmental impact from the raw material production to the disposal of the product at the end of life, it's called LCA. LCA stands for Life Cycle Analysis. If you start from the beginning and you stop the analysis at the end, this is called cradle to gate analysis. And this is the complete analysis of the product, which tells you which is the environmental impact of your product. We know that our composite materials are very attractive also from the environmental point of view. They are lightweight, so during the use phase you can save a lot of energy if you have to move them from one point to the other, like in transportation. They are repairable, so you can extend the lifetime of the component, which is normally shorter than the lifetime of the material. So the material is durable, but the application sometimes is much shorter than the potential lifetime of the component, of the material. So the possibility of repairing them is a way to extend the lifetime of the application. They are durable, this was already said. They are reusable. Even if you decide that your wind blade is not working properly anymore, you can use the large amount of structural material which is inside the blade for another application. And this is a new frontier of design. Design not only for use, but also for reuse. And due to the fact that our materials are very environmental resistant, they are very durable, these are the ideal materials for this design exercise. You can use the material much longer than the application itself. You can produce easily large items, and the material is recyclable. We will discuss a little bit about that in the following. Of course, there are some drawbacks, and those drawbacks are mainly due to the regulations, and that's the reason why we are working closely with the European Commission on that topic. There are legislation barriers to move products from one place to the other, especially if you have to cross borders, and especially if your material has been classified by waste. But the Commission is very sensitive to this problem because it's the same barrier that is preventing the recycling of other materials like plastics all over Europe. And so we are working together to see how to make it possible to transport waste across European borders by preserving the environment and the safety of the European citizens. And also there are logistics problems of transporting large items, bulky items, to recycle them. And the identification of the products is also something which has not been addressed so far. So how can you distinguish valuable composite materials from other materials in your waste streams? This is another point which has been addressed in the recent years. We estimate that the waste stream of composites is about 1 million tons per year in Europe. The expected growth by 2025 is 50%, so we expect that the amount will be 1.5 million tons in 2025, and the currently recycled material is only about 600 million tons. 1,000 tons. So there is room for growth, and we will see how we are working on that. So I anticipated that the life cycle of a composite is made by mainly 5 steps, The production of the material, of the raw material, then you combine the raw materials together to produce the part, and this is called conversion process. Then you have the service lifetime, which is, of course, different from the different applications: transportation, infrastructure, marine, energy, anti-corrosion. Then you may repair or reuse the material, and then you come finally to the end of use. This is a linear process, but now we are bending this linear process into a circular scheme, so we will see modifications of these in the following years, especially in Europe, which is leading the so-called Green New Deal of the world economy, of the industrial economy. We developed in the past 4 years a LCA analysis, life cycle analysis for the first part, which is called the composite manufacturing loop, which usually takes days or weeks to be completed. So we started from classifying the raw materials, fibers, resins, additives, flame retardants, cross-linking agents, all the chemical and physical stuff which you need to build your composite. And then we started also classifying the different conversion processes. And we published the so-called eco-calculator, which is a free online tool that any one of you can access. You simply will have to register to this tool, but it's free of charge, and which will make the so-called cradle-to-gate analysis. The gate, in this case, is the gate of the factory that is producing the part. We are currently addressing also the last step of this analysis, which is the end of use of the materials, and we will discuss a little bit about that as well in the following. So the eco-calculator, which is available directly from the EUCIA website, so you have a direct link to the calculator, allows composite manufacturers to calculate the environmental impact of their products in a very simple and effective way. So don't worry about, it's nothing complicated. It's only 3 steps. It will take you only 5 minutes without any burden to produce a very detailed report about your products. It generates an eco-report, a summary report, and also a file which can be exported for the use in some life cycle analysis commercial products like CIMA Pro 8.2. It uses a transparent and uniform methodology based on ISO 14040, and the high-quality environmental data which are inside the tool have been industry-generated, so they are true European data, and they have been also peer-reviewed by Ernst & Young, which was cooperating with us, together with BIINC, to produce the tool. We started with an original resin data set, 5 unsaturated polyester resins coming from 3 manufacturers, provided by the German Composites Association, AWK, in 2010. Data for glass fibers has been continuously supplied by Glass Fiber Europe since 2011. Thermoplastic and epoxy resins data, which are the other big category of thermosetting resins, has been kindly provided by Plastics Europe starting from 2013. So it's a very cooperative effort that we started in 2010. And data for carbon fibers, unfortunately, could not be supplied by the industry, and they have been obtained from different literature sources. And data for other components, hardeners, catalysts, cross-linking agent, etc., have been obtained from the Eco-Inventory Worldwide database. These are the input data. And we wish to acknowledge Reichelt, Plastics Europe, Ashland, AWK, CCP Composites, and Glass Fiber Europe for contributing to this effort. So the weak point is carbon fibers. Well, for some reasons, which are probably easy to understand, the industry didn't want to cooperate with this project. And so the support from the industry was not obtained. Data are coming from EcoInvent and from the literature. The reason for this complexity is that the process of obtaining a carbon fiber is quite complex. So there is a lot of energy contribution of the different stages, which is not that easy to quantify. And the values that are inside the calculator are calculated for the standard polyacrylonitrile-based fiber, which is a typical automotive grade. So it's not a high-end type of glass fiber like for aerospace. It's a low-end type of carbon fiber, which is normally used in the automotive sector. and the energy mix is based on the EU average. Sorry, this is really impossible to understand. This is however, it was intended to show you how complicated, and I guess the flavor is, can be easily communicated, how complicated it is to run this analysis from the back end, so from our side, not from the user side. So you will not have to go into those complicated tables. In any case, these are the database that the calculator is using to make, to produce the report, which is shown on the right. So the report will be a 3-page list of indicators, of environmental indicators, starting from the energy consumption, the GWP, the global warming potential. GWP stands for global warming potential, which is basically the emissions of CO2 that are associated with your process. The eutrophication, the water consumption, all those parameters will be listed for your product in the final report that is released by the eco-calculator. So you will have to you will not have to deal with those complicated calculations. The example on the right tells us which is made for 100% carbon. So it's a virtual composite made of carbon fibers only. Tells you that the energy consumption can be as high as 770 megajoules per kilogram. Just to give you an order of magnitude, the production of glass fiber is 20 to 40, and the production of the resins accounts from 80 to 120. So it's a huge amount of energy which is required to produce the carbon fibers, which is probably the reason why the industry didn't want to cooperate by providing industry-based data. Then you move to the conversion processes, and these here in this list are the processes that are inside the tool. And on the right top, you have the processes which are still missing, for which we are seeking for the industry cooperation. So if any of you wish to cooperate to improve, to increase the number of processes that are inside the tool, is more than welcome. What is missing is filament winding and centrifugal casting, hand layup, spray up, autoclaving, and BMC. But the processes which are on the list on the left, which are inside the tool, account for roughly 70% or even more of the entire European market. So the most important processes are into the tool. And this is the workflow. When you sign in, you will have to build your company profile, but this is not mandatory. The first step is to choose the conversion process, so how you are going to produce your part, by SMC compression molding, by pultrusion. So you will choose your conversion process simply by clicking on a menu. The second step is to create a recipe of your material. How much fibers, how much resin, how much additives, flame retardants, etc. are into your material. And then you press a button and you will generate the eco report. That will account for all the environmental impact from cradle to gate, so from the raw materials to the conversion process. And then you can choose to print your report or to export in Excel format or even in CIMA Pro format if you want to do further analysis, for example, for the use phase, which is clearly depending on the application that you are considering. So it's a very powerful tool. These are some screenshots. I will go fast. Define the product. You see there is a choice between some different type of products. In this case, in this example, it was a boat hull. You choose the conversion process, and in this case, it was produced by a resin infusion. So you click on resin infusion, and you create a recipe in kilograms. So you will have the mass of your part at the end of this process. additives, curing agents, resin, fiber reinforcement, different types of fiber reinforcement, because you can use unidirectional fibers, textiles, mats. So you can put all those data are there for the different type of reinforcing products. And then you generate your report, and you have the nice pie there, which tells you which is the split between the energy consumption, for example, of the production of raw materials, and the energy consumption associated with the conversion process. And usually, the most important contribution to the environmental impact is made by the production of raw materials, because processing is low energy intensive for composites. So it's not the big part of the environmental impact as for other materials. So that's characteristic of materials. The impact of the production of the resin and the fiber encompasses by 3 or 4 times, depending on the type of product, the energy consumption associated with the conversion process. So the outputs are what we call the eco-fat sheet. You see an example on the right-hand side, a summary of your project, the recipe, conversion processes, post-processing, etc. So the detail of your analysis. The eco-report in PDF or Excel format, and the eco-report which in the CIMA-Pro format, which can be used for further LCA calculation, for example, for the user phase. Which are the next steps? We want to extend our carbon fiber dataset, and for this we are seeking cooperation from the industry, and we are hoping that also the Turkish industry will cooperate thanks to the Turkish Composite Association to this collective effort in increasing the amount of data which are inside the dataset, to complete the dataset with missing processes and materials, to run regular customer satisfaction surveys. So if you subscribe to the tool, you will be asked to take a survey on what you need in the tool, which is not present at the moment. And you may also have the possibility to criticize it. To monitor the developments at the European Commission level, because the European Commission is also actively working to classify the environmental impact of the products that are on the European market. You all know probably that the European market has a CE approval, which is mainly for safety reasons. The European Commission wants to extend this to environmental impact. So in the future, and we think that will be a near future, listening to what the European commissioners are saying in public interviews, in the near future, every product which will be on the European market will have a PEFCR, they call it, Product Environmental Footprint classification. So the consumers, when they buy a product, would be sure that not only the product is not harmful, as it is currently with the CE approval, but it will be also not harmful for the environment, which is also a very important information for customers. And we are actively working on the inclusion of the recycling phase. What is recycling? We are currently surveying the reuse, repair, recycle conditions for composites. We are monitoring the waste streams and calculating them in all over Europe in different countries. And we are also monitoring the recycling initiatives in Europe. And it's quite surprising that more than 150 initiatives are currently active in Europe about recycling of composites. They are both European research projects, companies, and so also commercial initiatives or local initiatives at the level of local authorities. So there is really a big effort in Europe to improve the recycling of composites. And we have been identifying at least 5 different possibilities of recycling efficiently composite materials depending on what you want to get out from the recycling process. So there are a lot of options. So we are currently developing an online tool very similar to the eco-calculator, which will support the industry in the selection of the recycling options for their products. So the industry, I hope by mid of 2020, will have an additional tool to tell their customers that not only their products are not harmful for the environment, but they can also be efficiently recycling by listing the options for recycling for their products, which is something that really the industry needs. And we have been recently involved in an initiative of the European Commission, which is called the Circular Plastics Alliance, which wants to put an effort and a lot of resources to make sure that the European industry will be able to more than double the amount of plastics which is recycled in the continent from now to 2025. So this is a big commitment of the European Commission to help the industry to improve the quality of the recycling and the number of tons which is currently recycled and reused in Europe. So it's a very, very important initiative which was started officially in September this year, so the last month. These are some data which are currently collected by our consultants on the waste streams based on the gross domestic product model, which is a good model. So we have a complete set of data which is listed on the table on the right, and we are currently benchmarking this set of data which was calculated by our consultants by some real data, and we decided to start with the Wind Energy Association, Europe Wind Energy Association, because this is a very well documented process of monitoring the lifetime of wind blades. These are very big items, so it's easy to monitor, and we are quite happy to see that our data are in line with the Wind Europe calculations on real decommissioning volumes of the wind blades, although they are a little bit overestimated. So we are currently a little bit overestimating. We are ahead in time in some way with respect to the current data. But we think that this pressure of the European Commission to recycle more plastics, more materials, will catch up those two data in the near future. So this benchmarking activity, which was the first one, was quite successful, and we are currently in contact with the European boat industry to do the same. This is another very well identified type of industry. The boats are bulky items as well, so it should be quite easy to figure out what are the current volumes of boats which are being dismissed and potentially can be recycled. And the third one will be the automotive sector. We have the cooperation of the European Automotive Industry Association as well of the UPC, which is the European Plastics Converter, to work on this project as well. And we are looking also for giving routes for the end users to how to reuse their products. You see on the right a scheme in which materials recycled from the aerospace industry can go not only into the aerospace industry itself, but also in the automotive sector. So not only how to recycle, but where to sell the recycled material depending on the properties that you have. This is another very important information for the industry. So to summarize, EUCIA has developed an eco-calculator, which is a free online tool that the industry can use to calculate the environmental impact of the production of components. Data set has been 70% completed, but we still need missing data on processing and materials, so we need the cooperation of the industry. We need your cooperation. The recycling issue has been addressed, and the results are expected to be released mid-2020, next year. And we are aligning with the EU Commission initiatives, PEFCR and Circular Plastics Alliance are the two most important European Commission initiatives on these topics, and so is a must. And cooperation with the industry, of course, is more than welcome at all stages for all applications, including thermosets and thermoplastics. So, thank you for your attention.